WCSSP Southeast Asia is part of a global network of WCSSP partnerships that are harnessing the scientific expertise needed to strengthen the resilience of vulnerable communities to weather and climate variability.
WCSSP Southeast Asia has built a firm foundation of cutting-edge science, allowing all partners to develop and improve global and regional forecasting systems. In addition, it has advanced our understanding and capabilities to provide advice related to high-impact weather events such as heavy rainfall and the effects of tropical cyclones in the region.
A key element of WCSSP is enhancing the capability of each partner organisation to deliver timely, accurate and clear warnings of high-impact weather and help minimise damage and loss of life.
New tools have been co-developed with partners that are helping researchers evaluate and improve weather model performance, and these also help assist forecasters in Southeast Asia to more efficiently and effectively interpret the range of weather forecasting models that are available to them. This is enabling earlier and more accurate warnings of severe weather impacts to be delivered to decision makers, which allows them more time to prepare for a high impact weather event. Many of these tools can be potentially applied globally, allowing weather forecasters in other regions of the world to benefit as well.
The project has allowed Pag-asa to use output from the Met Office Global Weather Ensemble Prediction System, and this has significantly helped our forecasters in providing improved prediction and guidance to disaster managers for recent high-impact weather events in the Philippines, such as typhoons and heavy rainfall.
So I think one of the most benefit for our forecaster is that they are updated with the information that are useful for our forecaster to apply different information, even from the nowcasting to the very long seasonal forecasting, with different information from the radar application, from the ensemble forecast system, as well as for some long-term oscillation like Mud and Julian oscillation and so.
The project has now trained over 200 early career scientists and weather forecasters in Malaysia, the Philippines, Vietnam and Indonesia to advance their understanding of tropical weather prediction. Delegates have provided positive feedback on the improvements in their level of knowledge, which is helping them better analyze and interpret forecasts to provide earlier and more accurate warnings of high-impact weather events.
While traditional weather forecasts give an indication of what the weather will be, impact-based forecasts consider the vulnerability of people and property to the weather and warns of the associated impacts, as well as the likelihood of them occurring. It allows authoritative messaging to be delivered to all parts of society for taking appropriate action to ensure personal safety and protect property.
Met Office experiences of successfully implementing an impact-based forecasting system in the UK are being shared with researchers and forecasters across Southeast Asia. These activities are supporting the implementation of impact-based forecasting approaches in Malaysia, Vietnam, Indonesia, the Philippines.
The partnership has allowed us to strengthen impact-based forecast approach on the national scale in Indonesia to issue warning of extreme weather. In 2023, we are aiming to roll out the national implementations of impact-based forecast to all provinces in Indonesia, which will lead to significant benefits and help improve preparedness for weather extreme.
Before Typhoon Rai, locally known as that devastated the central Philippines, mographs predicted a high likelihood of heavy rainfall affecting Cebu province, which provided the basis for Pag-asa to issue an IPF red warning.
Through this project, we managed to perform numerical model prediction up to 1 kilometer and also 300-meter resolution for the city of Kuala Lumpur. This enabled our Department of Irrigation and Drainage to use the NWP model to drive their flood model. Grateful also to this project because we also managed to design our own impact-based forecasting model for Kelantan and Muar River Basin in Malaysia.